So we are live and we get the participants are coming on in here. Um, what we're going to do today is we got a very cool webinar for you. We're going to try and touch on 4 different events with our national experts to give you some tips and tricks to kind of get you ready for your regionals and the upcoming state tournaments. So glad you guys could join us. If you would please, in the chat, go ahead and put um, your name, school, and team, what state you're from. By way of introduction, I'm John Lohr. I'm with the national office here at Science Olympiad. And on screen are 2 of our presenters, Brian Hoffman, who will be talking about a couple of events in a minute, and Greg Marconet, who will be taking care of towers towards the end of the presentation. Couple of housekeeping things. First of all, this is being recorded. Hopefully you heard the announcement when you logged in. We'll clean up the video, make a couple of edits to it, and it will be made available to you. You will be sent a copy to the email address you used to register. We also post it on the Science Olympiad YouTube channel, Science Olympiad TV. And we'll also have a link to that video on the workshops page. That'll probably happen a little bit later this week. So you should have it. We'll try and get up there in time for the weekend for everybody. The second thing, if you have questions, you have 2 options. I will tell you the better option is to please use the Q&A feature to throw your questions in question and answer. But if you can't find that, you really need to do that. You need to go ahead and feel free. You can drop stuff in the chat if you want to. Okay. On that, let's see. On that note, I'm going to turn it over to Brian, and he's going to talk about Robot Tour.
Here. And let me just start sharing my screen real quick. All right. Good. Everybody see my screen, I assume, John, right?
Yep.
All right, perfect. All right, I'm going to start off with Robot Tour and everything else. Again, it's a relatively new event this year. It's our first time in, so there's been a lot of questions. First, again, Brian Hoffman, I'm the national event supervisor for this. So I'm either the guy you like or you hate because of the rules. So, and we'll end up trying to explain a little bit of this and go through and show where teams are doing well and having issues. So with that and everything else, let me just go through this. So one of the things is right off the bat I'm getting is, hey, what is a typical score? You know, what should I be trying to do and everything else? So one of the things, this is about 5 different tournaments that I've pulled some scores out of. Give you an idea a little bit where teams are doing. So, I mean, a lot of this is just more like failed runs. These higher ones are, they're teams that just aren't quite ready yet. So, but you can see the bulk of the teams are really down here. And you get some more of the earlier tournaments and everything else. And as we get later into the season, people are starting to figure it out. And this is where I'd like a little zoom in here. And again, for a regional tournament and everything else, perfect score would be about 55 points for regionals. So a lot of the teams are getting into this. Now, how do we get there and everything else? Just to try and explain a little bit where teams are seeing. Well, one of the things is your run score is really your time score, your distance score, plus gate and penalties. And its lowest score wins. And these 2 graphs, I mean, the biggest part of your score is your time and your distance. How close are you to that target? How close do you get to the time? You can really see the bulk of the teams are doing okay on distance. They're getting within close and everything else. But what we're seeing is a lot of the teams are struggling on time. Time is hitting that time. So if the target time is between that 50 and 75 seconds, what we want is that team to be as close to that target. So if it was like tournament I ran over this past weekend was 71 seconds. How close can you get your robot to stop at 71 seconds? And so that is actually one of the bigger issues, trying to get teams to do there. And that's where they're struggling. And one of the biggest things is motor speed control. It's very important how you control your motors on this. Because to be very clear, Robot Tour is not an event where the fastest robot wins. It's the event where you control that speed of the robot. I watch a lot of teams They just sit there and they're done within 15 seconds. Well, if the time 71 seconds was your target, that's a problem and everything else. You're way under. Now, just to be real clear, I've had a lot of people ask me questions. It's like, hey, why isn't fastest wins? Well, to be very clear, this is actually based on real world. If anybody's ever seen an Amazon warehouse or a lot of them where they have all those robots moving product around in a warehouse, Robot Tour is based on that. And in that, we have a government agency called OSHA that actually limits. I am not allowed, when I program a robot in a warehouse, I'm not allowed to travel beyond a certain speed. I actually is considered dangerous. So we've applied the same thing here to Robot Tour. That's why fastest doesn't win. That's why we have a target time. Just like in the real world, you can't have a robot flying around people as fast as possible. So, and the way you do that is motor speed control. Now, again, we only have a few minutes. We have quite a few events to talk about today. Up on Scioli, I've actually put quite a few threads with different students I've been talking to and everything else. And a lot of these graphs are up there explaining what poor speed control is, what good speed control is. How do I know? How do I pull out of my robot? I generate a graph. And I've had quite a few students doing that. So I'm not going to go into the details on that here because we just don't have enough time. But there's a lot of threads up here to go read that explain this quite well. A couple of the other things is this is about position tracking. You really need to know where you are on the track. And that's where you really want a motor with an encoder. Again, encoder allows you to do distance tracking because the teams that seem to be doing really well are the ones that are just doing a simple kind of, hey, I need to go forward, left, forward again, left, back and forth. They're coming up with a series of commands. Because again, your students have that 10 minutes to set up and program the robot and then 8 minutes on the track. So they really want to come up with a simple way to program this each time. So that's where they want to come up, create a list. I've had a lot of teams come up with, really, I watch them, they get to their 10 minutes and they're done and they're now using part of their 8 minutes on the track time to finish their programming. If that's the case, they didn't come up with a simple method to do it. They should be able to do it well within the 10 minutes and have extra time to spare to go through and test things. Test things as far as, again, you can't actually test the motions, but you can hold it up in the air, make sure it still moves, put the batteries in, things like that. Now, the next thing is to also, as far as least amount of moves. And this is a really good exercise I did with my students and everything. This is where I ended up, okay, here's a track, typical track. Go ahead and I had 4 students and they literally all came up with the same idea. They were going to drive the robot around like this to get to the target point. And we went through, okay, you did 9 straight moves, you did 8 turns, and you did 17 total moves. And they go, well, we can cut that back. Instead of turning around here at A, we'll reverse. We'll go backwards and only turn. So we'll cut one out. Okay, so now instead of 8 turns, you're 7 turns, and your total is 16. I said, let me show you mine. If I end up doing this, going around this direction with no reverse, I'm 17 straight moves, 6 turns for a total of 13. So without reverse, that's 17 movements versus 13. With this event, this is about optimization. The less you move, the less you churn. Every one of those churns, every one of those moves is a potential for more errors, for more things to go wrong. So it's, again, this is really about trying to look at strategy. And I watch the students come up now, the ones that are figuring out are counting, okay, I can do this in 17 moves. Okay, I've got this in 13 moves. They're figuring this out. They're actually counting how many moves they're doing it in and trying to find, because every time you can make it simplified, again, the simpler it is, the better that event is going to be, the better it's going to work for them. So it's a really
Brian,
good, yes.
before you go on, 2 questions have come in.
Oh, yes.
All right. First question from Adarish is, will the distance of each section of the path be given? Example, 50 centimeters, 110 centimeters, etc.
Yeah, good question. As far as this is, again, where the track is 2 meters by 2 meters. So it's already laid out as a dimension, and each of the subgrids is 50 by 50. So that's already laid out by the event supervisor, the definition of the track. So the students in their practice should know that, hey, this first move needs to be, say, 40 centimeters to get my robot, or I have a bigger 60 centimeters to get into the middle. And then I know, okay, center to center is 1 meter. So that's actually part of the track definition.
Okay. Second question here, and this is from Lavish, is how do you suggest to code with encoders? They say many of the encoders they have looked at online and have tried to do, the distance traveled isn't being accurately reported.
Okay, that's where I do have a website, topfinish.kits. Doesn't sell anything. All it does is give away suggestions and tips. And there is a sample program up there that actually works quite well. Now, the only thing is that sample program is what I like to call is detuned, meaning is it sort of walks not in a straight line and everything else. It curves because the students need to go through the code. I'm not going to give somebody code that's perfect. They need to go through and figure and optimize it a little bit and understand it. But as far as I had a student use that code, actually the top 3 teams actually at Saturday's tournament all used that code after heavy modifications and finished in very well. So it's a really good place to use and everything else.
All right.
So
Then there's another question here that says, once the programming changes are made, can the program be downloaded to the robot over a Wi-Fi network? They go on to say the Wi-Fi network is created by the robot and can only connect to one laptop since Bluetooth communication is allowed.
no, we've generally said Wi-Fi is not allowed because it's more Bluetooth, because that's more of a one-to-one. Wi-Fi is more of a one-to-many. So sorry, I had to put a limit on that. Wi-Fi is not allowed.
Okay, so you cannot connect the device to the robot over a Wi-Fi network.
Correct.
All right. And then last but not least, we're saying there's a question here about using motors with a 540 encoder pulse per revolution, but they're still getting distance inaccuracies of approximately 10 centimeters.
Exactly. And actually, the next question is, how do I tune the PI loop with the top finish kits? That's the next question also. That's literally go to these threads on scioli.org. And that's actually, I've had quite a few teams ask this. And this is actually the program that's up there from Top Finish Kits. This is the output of that robot. And as far as if you have it detuned, if you haven't tuned it, you're going to get a curve. It looks like this red one here. And it's not going to be very accurate because this is where you wanted to stop at. Versus in this case, you wanted to stop, you want to get this blue and red as close together as possible, like is what this is showing. And it's actually the program, this is an actual output. And I just worked another student, as far as from another school, had some questions up there in Scioli, and we walked him through it. And as far as he's actually got it doing much better, he was having that issues. It's again, it's a sample program. You need to go through and understand how to tune, do a little research. Can't give away everything. Students have to do some work. So, all right. Let's see. The other one was
If you want to quickly try and tackle Darren's, otherwise we are really up against time and should
okay.
shift to wheeled vehicle.
As far as, yeah, real quick, just in general, I'll ask as far as you really want a robot that's good with excellent speed control and positions, because one of the things I've seen is I've had a lot of teams with Legos, Vex, and very expensive robots. The one thing I've been very happy about this event is the more expensive devices are not having an advantage. The Legos work fine, the Vex work fine. The simpler kits that are the $50 to $100 kits are competing just as well. The one thing that I have seen is I've seen a lot of teams do very complex programming, very complex robots. They are not doing well. They're getting carried away and trying to overcomplicate the event. Keeping it simple is the most important thing. So, all right. So, as we're time-wise, move on to the next event then on the wheeled vehicle.
Yes, sir.
Okay. All right. We're going to cover a little bit with wheeled vehicle at this point. Again, Real quick, if there's still more questions on robot, I do monitor Scioli as far as for questions and things on that and trying to answer through that. So a lot of good stuff there. All right, for wheeled vehicle, again, I'm one of the event supervisors for this one also. So we'll try and do some things. Again, what's the typical score? I thought this is a good place to start again. Wheeled vehicles been around for quite a while, or just the vehicle events in general. So what we're seeing is a lot better out of the scores and everything. You still have some teams struggling early on, trying to figure it out, but as you can see, as we're getting later in the season, I've been noticing teams and so on, we've been getting much better and everything else and what we're seeing. And again, what is really a good score and everything else, this is again where you've got the teams they're figuring out the can bonuses. These are teams that have actually figured out the can bonuses. These are teams that are running basically more in a straight line, not trying the cans yet. So they're being competitive with each other. So it's really good to go with that. Okay. As far as what matters more? Well, let's look at again, one of the biggest things I've seen is like a run score is 100 points plus distance plus time score, can bonus, log bonus, and penalties. Well, if we look at two things, we have the distance score and the time, their run time. The run time, all the teams are between 2 and 5 seconds. Everybody, the time is really not the issue here. If you look at the percentage, where your score is coming from is that distance. If your team's trying to figure something, you want to really concentrate on getting that distance as close to that target point as possible. That's what really matters at this point. And that's what we're seeing teams do and everything. So it's again, speed is not your friend. I don't know how many teams I've seen do this is they wind up the car or their vehicle with as much energy as they can. They're using that fishing pole, they're using that rubber band. And I sit there where they're almost breaking the car, putting so much energy into it for no advantage at all. If you're under 5 seconds, you are fast enough because that distance, that's where that score is coming from, is that distance. It's not coming from time. So if your kids are really trying to go for that speed and they're having problems, slow them down. Get them to go slower and everything else. So, okay. Now, one of the things I have seen quite a bit questions a lot of times from students is like, hey, but my vehicle needs a lot of power to reach the end of the target point. I've seen kids go, it's like the students are going, they're really winding up. They're putting a lot of energy into this because they're trying to get it down there. And what we do is we ask them, hey, can I look at your vehicle? And one of the greatest tests I do is I pick it up and I spin their wheel. If that wheel should spin, if it does 2, 3 revolutions, they have a problem with the axle. But like for all the ones I've seen that don't have that issue, it spins like another 20 revolutions on its own or more without any issues. And generally what we find is when they put it on the threaded rod, they tighten things up too much, that they actually get the wheel in here rubbing against each other. And that's one of the biggest problems we've seen is that they end up tightening that up way too much and everything else. So, and that's a real quick test to do that. And once they figure out, oh, I don't need much as power anymore. So, okay. Moving on. Now, I did see a question and everything else talking about the precision. Is there a way to get the actual turns more accurate and everything else? That along goes with there is a video up on both the Scrambler and wheeled vehicle site for general vehicles, and there's one on braking. This is, I highly recommend your students that walks through and everything else. How do you do the math? How do you figure out to make this very accurate and everything else to get those turns in correctly? So, because one of the things I watch more and more is I'm seeing teams are guessing and everything else. They're not doing the math because one of the things I really laugh at is not laugh, but it drives me crazy is there's no calculators. I don't know how many teams I see that don't have a calculator in their box because they're like, okay, I missed by a meter. They go, throw 4 more turns on, is what they literally do. And I had my team itself lost this past weekend and everything else because he goes, well, I guessed. You had the calculator in your box, pull it out, run the math. So that's one of the bigger things is I see teams are out there and then under that pressure and everything else, they're guessing. They're not actually running the math. And that's one of the biggest things, especially as in a vehicle event where we have a curve, you get as far as the vehicle, it's like it stops here and they look at the distance. The first thing is I see teams all the time, where's your ruler? Why aren't you measuring what this distance is? Because the thing is, they'll ask the event supervisor, they'll ask us, hey, what was my distance? Great. We tell them this distance because this is for your score. We measure this distance. Their correction is this distance, this blue one is the brake turns. So if they use this one, they're going long. Because the other thing is this little distance off, which we'll get into, is the aiming correction, is how much they miss by. Because again, I see students guessing all the time because whatever they did for the first run, they should add in, whatever this brake distance is divided by the wheel circumference. That's how many turns they should do for their second run. So again, rulers, calculators, math is their friend. If they're just guessing, well, that's where a lot of that errors come from. So, okay. I did see a question as far as how to make the vehicle turn up on again on the wheeled vehicle site and everything else. And Scrambler, there's a video on turning. It's a very simple, basic video that walks through a little bit the concepts behind how to get a car to turn. And on Scioli, again, there's some other little graphics and some other conversations talking about how to even fine tune it beyond that. So there's some really good resources for that. Okay. Moving on. All right. The other thing is, I don't know how many teams I watch just sort of stand by behind the vehicle and they eyeball it. They're just trying to figure out where it goes. They really need to have some kind of method, something on the car, something they set next to the car that allows them to aim it to know where the car is facing. And again, one of the things we've seen in little bit questions is there's a curve because again, we get a bigger bonus for going between the cans, which means the car is got to go through this. But one of the other bigger problems we've had is I've watched teams, they've got this curve and they actually you have to put a target out here for what you're aiming your car to. And I've watched them put their target, they're like, hey, you set us up an illegal track. I go, listen, I can't help it. There's a wall here. There's a wall. You can't put your target out in the crowd. Okay, you have to stay within the track boundaries. Because again, event supervisors, they're only required because we're tight on space sometimes to provide what the limitations of the track is. So you really want to come up with a method that keeps that target, that sighting device, whatever your target you're aiming at, on the track. Because if you don't do that, you could be like a team. It's like, well, I'm sorry, there's a wall here. I can't do anything about that. That is the event space they gave us. So another thing is to be really careful. We've actually, on that point, as I've had quite a few teams this year, try to go that vehicle where it travels well past, so it'll go 3-4 meters past the target point and try and come back. Unfortunately, we've had a lot of events where we don't have that kind of space to give you that 3 or 4 meters beyond it. So it's unfortunately, this is travel to a point and stop, not travel past a point and come back to it. That's other years. So that's some of the things. Okay. As far as I see some other questions, our team tried to use this formula and missed and everything else because of the curve. It does work because that's one of the other things is last thing I want to go is like, how do I know I am doing well? How do I know as far as my students are performing well? Well, one of my favorite exercises is to have them run the vehicle several times. No changes. I want same turns, same aims, same everything. Run it like, at least 6 times. And then what you do is you take a piece of tape and you mark the floor every place they stop at. And I've done this many times. And I always love asking students all the time, okay, here's 3 teams. Which one is the better team? And a lot of them I'll get, well, this one, they got the target. They actually got really close. These other ones, they're not near the target. So this is the better team. In reality, no, I can actually use this and look at, oops, go back. This is the better team because, okay, they had some aiming and they had some distance wrong because they're stopping short. But they have a very nice tight grouping on all their points. That tells me they're doing the same thing over and over. And like number 3 is a really good example. This team, they've got the distance right, but they don't have a good method of aiming. They're going left, they're going right. So they're having issues in aiming the car, but they're actually stopping at the same distance each time. Versus really this team here is probably got a combination of aiming and distance. They're having issues with the brake turns. They're having issues with the how to aim the car. And it could also be performance in the car. But this is one of the biggest exercises I do all the time is let's just, okay, today run it 6 times the exact same. And it's amazing to watch. And I'll walk up to the students and I'll go, okay, hey, what happened here? Well, I bumped the car. But you still ran it? Yeah, when I was aiming, when I took the scale or the scope off, I bumped it. Okay, well, start over. You ran that anyways, knowing you did something wrong. And they're like, yeah, I now see that and everything else. So they're starting to get that idea. You can walk through 'em. The students will start figuring out why these points are all over this place. So it's really a good exercise. So, and again, yeah, what are the main factors is a question I see is as far as for precision and consistency. One is the brake turns. One real good example I have with the brake turns is I always explain to students that is the last thing you set. I don't know how many times I will see students set brake turns first and then do a whole bunch of other work on the car. They'll wind the rubber band. And meanwhile, they don't realize that brake turn, they bumped it, they hit it, it moved off is one of the big things. Or one of the other things is who's aiming. My favorite is student A versus student B is watching how they aim the car is completely different. And one of the biggest things is I will have one student aim and then I'll have another two look at it. Do you agree? And I'll have them to go down and look at it and they go, no, 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 you're 3 centimeters, you're 10 centimeters off. So get the students to double check each other is another thing. And they'll slowly start finding a lot of their little issues is some of the other stuff that you'll see with it. So I think that was all the questions. Yeah.
One real quick one, Brian, that's sitting in here, and it has to do with, can they use store-bought wheeled vehicle? And if they do, what do they need to include in the design log?
Okay. As far as that is, we consider designing the selection of something purchased. Now, that has to be a car the students have to assemble. It can't be, hey, open up the box, it's ready to go. That's not designing is like, hey, here's 3 different kits. Which kit do I buy? That's part of the design process. But then they have to design, put it together. Again, there is no design log for wheeled vehicle. There's only a practice log, and that's a bonus. So hopefully that answers that.
All right, it does. And if you, we're at time, so if you want to move on to Scrambler, and we're making Brian do extra duty because we had a last minute cancellation, but he's going to cover Scrambler for us too.
Okay, and it's a lot the same. Unfortunately, I didn't put this together, but Scrambler ends up coming in about really close to the same score wise and everything else. I'm seeing teams, getting down. The really good teams are getting below 20 points, but the bulk of them are still in about the same area here score wise, is what I'm seeing for Scrambler, just to give you an idea. And the same thing applies is speed is not, it's still about the same. Is we are for the most part seeing between the 2 to maybe about 6 second cars is what we're seeing in everything else. So it's about the same thing, and distance is everything again. Is that distance is really what matters. So same thing applies to that event is that you really speed is not your friend. I know there's a lot of teams that are trying to get down to there's a couple that are trying to get to under 2 seconds. They're successful, they're doing it. But the problem is, remember, there's that egg on the front of the car. You get the distance wrong, you get a wheel turn wrong, you are breaking that egg for that 2 seconds and everything else versus, you know what, let's play it a little safer. Because again, when you break that egg, there's a big penalty and everything else with it. So it's the difference is unfortunately, you're no longer in the top 10, you're going to be way at the bottom if you break that egg. So that's one of the things that's really neat about Scrambler and why it has that risk is you really need to control distance. Distance is everything. Um, so That's one of the things. Now, as I did see a question in here and everything else is like, how do I get my car faster? I know there's a lot of teams that like in the early year struggle trying to get past that second timing line at 7 meters. It is the same thing. I will pick up their car. I will ask them at a tournament after they've run and everything else, can I look at your vehicle? The very first thing I do is I spin their wheels. And it's again, same thing. I am seeing their wheel only spin 2 or 3 times, or I can feel it dragging. And it's really, and that's where they don't realize again, they've actually on the threaded rod, they've tightened this up so tight that they've ended up binding it up and everything. So that they're ending up seeing as far as way too much friction. Because to be honest, as far as the dropping weight, one of the biggest things I do, and this applies for wheeled vehicle or even scrambler, have them push it down the track. They should be able to give it a really nice soft push, and it should continue down the track on its own. If it feels like it's dragging and everything else and having those issues, that's again, it's friction. Something is going wrong here and everything. Now, the other thing with Scrambler is I've watched teams build very, very heavy vehicles. They're making these things out of a lot of weight. Because you only have that 1.5 kilograms you're dropping, you want a really light vehicle. The lighter the vehicle, the better you are. Because now you're not, for 2 reasons. One, it's easier to get down the track. Two, if you do happen to hit the bucket or do happen to hit the terminal barrier at the end, the heavier the car, that's the more weight. It's a sledgehammer coming in and smashing the egg. Versus if it's a really light car, it's not going to have that energy to break the egg. And we've actually had quite a few times where we've watched it hit the terminal barrier pretty hard, but it's not enough to really break the egg. It puts a crack into it, and again, you put the paper towel to it, it doesn't leak, so they get lucky. But it's because the car never had enough weight and everything else. So you really want a car with not a lot of weight and a car that is actually very free spinning wheels. Those are the most important 2 things in this event. So to get it down there. And again, the same thing applies. You want to use that wing nut braking system. So again, there's that general video and everything else up there that explains braking. It walks you through the math. And again, too many times with the students, again, they don't have calculators. They're not sitting here measuring what they're off. Have your students watch a lot of the teams that are getting close. You will see a lot of those are out there with a ruler measuring how much they miss by. Because it's very important, because this is a break the egg, you're done. You want your first run to be very safe. You don't want to push it and everything else and get really close to the terminal barrier on your first run. You want to do basically a safety run on your first one. And that's where they want to then for that second run, they want to measure. It's like, okay, if here's the terminal barrier, how far away am I again from this? And the same thing applies. They don't want to use the distance score that we give them for their score. They want to measure that distance from here to the terminal barrier. That is how many their brake turn correction. And then again, they have an aiming correction to go along with that. So same thing applies here. Again, whatever they did on the first turn, look at that distance, divide it by the circumference, and it should be able to then make that correction to move it in closer.
Hey, thank you, Brian. And brother Nigel has just been able to join us. Welcome, brother.
Hi, hopefully things are working. Sorry for the delay.
No worries, sir. We are talking about Scrambler, and we have a couple of questions in I'd love to get your opinion on,
Okay,
if we could. All right.
sure.
So this first one has to deal with kind of the I guess the launching setup. So here's how they ask it. For Scrambler, are we allowed to tie some string to the end of our number 2 pencil? That way, when the pencil's pulled and the weight drops, it's also releasing a latch that is holding the vehicle in place.
Wow. Yeah, that I need a. Can you repeat that one more time so I can get an idea?
Sure thing. So, as they've asked it, are we allowed to tie some string to the end of our number 2 pencil?
Right.
That way, when we pull the pencil so the weight drops, it also releases the latch that is holding the vehicle.
I don't know. Brian, what do you think?
Yeah, that'd need a little bit more to see. It's again, I've seen it as far as where the string is connected to the back of the vehicle through some kind of hook, and the weight's trying to pull. And so basically, you're more holding the, I don't know about the latch, but you're preventing the weight from falling with the pencil.
Yeah.
The latch is what's a little concerning. I don't know quite what that is either.
Okay.
I think, I mean, to be perfectly honest, I think if you are event supervisors around the nation would probably have an issue with that because it's something that I don't think I've ever seen it. Yeah, I can't, if it doesn't add energy, technically it should be okay. If it's not adding energy to the propulsion, the energy has to come purely from the falling of the mass.
So then we're going to say to the advice to the poster, it's probably, you're probably pushing the envelope a little bit too much with that one. And if you, not to say if you want to give it a shot, but do not be surprised if you run into some problems with the event supervisor. All right. Because there's some a lot of gray area.
Yeah, that's a great way to put it. That gray area is not where you want to be because you're going to have one event supervisor who doesn't see a problem with it and another that may.
So, all right. So Rosemary asked this one: when lining up the Scrambler launcher, is the car set on the start point, or is it the front of the launcher that's set on the start point?
The only thing that's on the set point is the tip of the egg. The launcher can be at any angle. The car can be at any angle. The thing that we're going to look at is the very tip of the egg has to be on the over the start point itself. So you're going to have parts of the thing at different angles. There is no start line anymore. So really your device can be angled at any particular angle in relationship to the terminal barrier and to the bucket. So the only important thing is the tip of the egg has got to be over that point.
So then this one comes in, it asks on, I guess there's something on their first run, if you crack the egg, but it does not leak, are you allowed to swap out a different egg for the second run?
No. No, I'd say you're given one egg, provided uncooked. Yeah, the one that you choose is the one that you stay with. That'd be my call.
Okay.
Ryan?
Agreed. Yeah, you don't get to switch eggs.
Yeah.
All right. Then this one, and I apologize, I think it's Rahab, is looking to for some guidance around setting up the curve to deal with the bucket. And I think Brian talked a lot about this a little bit in the wheeled vehicle stuff, but any comments you guys have about helping them, get that curve set up smoothly?
Yeah, again, I mean, brother, if you don't mind me real quick.
Go right ahead,
As
Brian.
far as on the Scrambler website and wheeled vehicle, there's a video up there on how to do curves, how to do, because the steering, how to get it to curve and everything else that explains a little bit. And again, and then go to Scioli has, again, a lot of other good examples up there of conversations on how to help you with that curve.
So primarily, and just the synopsis is, in the end, you need the two axles not to be parallel to each other. Either that, or you have to turn the individual wheels. But if the easier way to do it is just to have the front part on a bolt that's got a lock nut, and you can actually turn it for whatever angle that you need to go. But that's part of what you're doing for your calibrations. So you should have a whole like series of marks on it that if it's going to be this distance, you want to have the axles at this angle to each other, then this angle, this angle, depending on what is the choice of the length of the track.
Brother, we're getting to a point where we're going to jump to towers. Do you have any kind of tips or advice you want to give the Scrambler folks, or things they should be aware of as they're coming up to competition?
Yes. Do not practice with real eggs. Go out, buy an Easter plastic egg, fill it with enough material to get about 65 grams, and use that in place of the real egg itself. You do want to have that weight on it, and you do want to know that distance, especially if you want to be really, really good. So a plastic Easter egg or a plastic egg that's the same size as a grade 8 egg is a great way to calibrate it and not have a mess all over the place.
That's awesome. You said 65 grams is about a decent approximation.
Yep, it's a ballpark. The eggs are a little different on it, but an average grade 8 chicken egg is about 65 grams.
All right. Okay. Anything else, anybody?
Calibrate, 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 calibrate.
Okay. Now at this point, hang on. We're going to bear with me one second. I'm going to jump and go to towers, and we're going to turn it over to Greg and Chuck. And guys, I will pull up the slide you sent me.
Okay. Hi, everybody. My name is Chuck Stakovic. I'm the event supervisor for towers for Division B. And Greg, why don't you introduce yourself?
Hi, I'm Greg Martinet. I'm Division C event supervisor out of Wisconsin.
And we put together a list of a few last thoughts as you go forward to regionals and to state, and we'll go through them and then we'll answer Q&As at the end. From a design perspective, obviously, the tower needs to be a certain height and be able to span the opening and the test apparatus, but I wanted to remind everybody that they should be pretty confident if they're going after the bonus. That's where the legs have to be outside the 29 centimeter circle, that they have to maintain that touching outside the circle for the full loading of the 15 kilograms to get that bonus. And that is a trade that the students will have to do to get that 33% increase in load, which is 5,000 grams added to that. And if you really are a good builder for your tower might not perform like you expect it to, because the base is not true and square. And so what's really important is that the students make sure that for four-sided towers, that the legs on the bottom are not wobbling, and that the load block that goes into the top and the positioning of the pieces of wood that hold the bottom of the load block are not wobbling. And that when you put the load block on there, that it is level and flat, parallel to the test base to provide that force straight through. Otherwise, you're going to be applying some lateral or shear forces when the tower tries to correct itself. And so it'll break prematurely. And so it really is important to make sure your towers are true and square. Also, the students should be have no doubt that they meet all the construction requirements. There's checklists out there on the websites that they can use at home to go through, and the rules, looking at it line by line to make sure they meet all the compliance checks, to make sure that they go into the tournament with no doubt that they meet all the requirements. Now for Division C with the design log, again, we provided the template to be used and populate for the things that we're looking for, and it'll make it easier for the judges to verify compliance. But with the sketches, you make sure you need to cover all the key dimensions, angles, and features for each of the towers. And at the state level, you'll have 3, but at the national level, you have to have a minimum of 4 towers. So you need to have that objective evidence that you've done those towers with evidence in the design log and sketches to get that 1.25 multiplier to the score. And as with a lot of these events that we've talked about, it's really important to practice, know how to efficiently mount the tower on the stand, know how and who is doing what with the hopper system, or if it's a manual system, who's scooping, who's going to stabilize the bucket, but actually practice that process as they go forward and get efficient with that.
Well, now that you've built your tower, you've got to get it onto the competition, right? And last weekend I had 2 towers that I would call DOA, in other words, damaged on arrival. The towers tend to be very fragile, as they're sub 6-7 grams. So you do need to make sure that you protect it all the way to the check-in table. So a nice little box, maybe with some packing around it to absorb any impacts that may happen on the bus and that. A lot of people like to manage the humidity, and they'll put a small desk and bag in with that sealed box. That's fine with me. Weather in Wisconsin is not that humid, so we're not too worried about it right now. But come spring, it may be an issue. And then also kind of goes along with that is the idea that don't forget your eye protection. The Z87 Plus goggles, as well as your design log if you're in Division C. So it all goes together, making sure you get everything to the test, successfully. Chuck mentioned it, but I can't stress enough that you need to practice setting up your tower at home. I won't go over that again, but I'll tell you that last weekend at a meet, and I've seen these people a couple of times, they struggle with a lot of time. They waste a lot of time trying to figure out how they're going to get the loading block on and the chain through. So a little bit of practice back at the school or at your home really serve you well. Also, be ready to answer your check-in questions, right? You're supposed to have an estimated load scored. And so think about that, do your math on it based on the tests that you've done, and be ready to answer that question. And as Chuck mentioned, also be ready to go either way, whether it's a manually scooped or a sand hopper type system. Know what that means to you and how you want to set up your tower, as well as who's going to do what. And then finally, just have a good time while you're up there. We want you to be relaxed and have a great time testing the tower. It's a place where we can do some learning. Certainly, as the test unfolds and we see what happens, I think a lot of the event supervisors would love to help you. And we'll probably give you some suggestions along the way. You should also be ready to just chat about how your work to get ready for the event went. Thinking about things about, just how did the build go, and if you have some questions along the way. So those are some things that we thought might help you as you get ready for the event here.
And I do want to say that on the Science Olympiad YouTube channel, there's quite a few videos that are very, very good for students. We put some of them on there. Some other people had posted really good information for the students. So make sure you take a look at those, and there's lots and lots of information on the videos.
And then I see there's a couple of questions in the chat here. One is, if a tower breaks just after all the sand is poured out, will it get the bonus? If it is a bonus one. So yes, if you've held all the weight and the event supervisor can see you've held all the weight, and you're also spanning the 29 centimeter circle, it can fail seconds after it's held the whole weight. So I had one this weekend that is exactly what happened. By the time we got to the bucket, we had confirmed that everything was in there, out of the hopper. But by the time we got to taking it off, the tower did fail after a couple seconds.
Yeah, I'm gonna address the one question about the prohibiting label in the wood with mass density and stiffness. We had a couple of questions come in through formal FAQs, and we caucused around this, Greg and myself, as well as with some of the officials in the organization, about how much is too much and whether we should allow this, and what kind of consequences we have if we make it difficult for the judges to determine it. And so I can give you my position from a judging perspective, and then I'll give you my position from a coaching perspective. And that is, we really put in the rules that excessive glue is not appropriate, and the use of tape and paper is not appropriate because it changes the characterization and the performance of the wood. And so any inking, it's hard to tell what kind of inking it is, whether it does have kind of like a Loctite blue or red, or whether it's clunky, or whether it's just from a Sharpie. And it makes the job for the event supervisor hard to say, is this thing really changed the properties of the wood or not? So we wanted to stay away from that and make it clear that we only want what I call witness marks, which is on the ends of the wood that you would mark for where you cut it. And that's allowable as part of the construction process. But on the coaching side, because I've coached this as well as made a lot of these myself, when you're looking at light towers that are competitive, and you're looking at the dimension of the pieces that we're dealing with, there is an industry standard called bag and tag, where you identify and segregate pieces and put them into bags for if you want to kind of segregate groupings of densities and those kinds of things. And we sure don't want to have the students try to use a pencil to score the grain of the wood, which is always a bad idea because it could, create some fracture or some weak point in the members. And so from a coaching perspective, I would tell the students to stay away from that as well. But this is really the official response that we have applied to the FAQs, is that no, we don't want any of that kind of marking on the piece of wood at all. Only that we expect small amounts of like a mark indicator on the ends of it to show where the students had cut the wood is acceptable, but no other markings. So I don't know if
So
that's
just
going to be contested more or not, but that's kind of our position. Greg, I'm sorry.
Yep. Just to finish up NK's question about a team appealing a leveling issue with an apparatus, that gets very tricky. So I know that I level the test apparatus very carefully at the start of the meet, and I don't move it. I don't adjust it after that, because the Science Olympiad says that, hey, if it wasn't level, everybody's got to see the same test stamp. And so it would be hard to level it in the middle of the meet. It would change the testing of that day. So that's probably a better question for the arbitration board, but that would be my opinion on it.
But Greg, you are 100% correct.
Okay, good.
You can put that you can put that request in, but it's not going to be granted because since it changes the conditions for the test for the day, and we can't have teams that already tested go back and compete fairly.
So yeah, maybe the only suggestion we can make is that get there before the meet starts and talk with the event supervisor about how they leveled it, because if they find that there's something they want to adjust, they could do it before the meet started, but that'd be about it.
And also the teams need to keep in mind that if there are multiple test apparatus being used, you do get to make a selection as to which test apparatus. So, I guess choose wisely.
Mm-hmm.
Yeah,
Okay.
there's a couple more questions here related to design, if you want me to take those, Greg.
Go ahead.
Yeah, something like, is there a maximum base width or height for the tower? Again, we've put the minimum requirements for height, but there's a pragmatic approach. You don't want to have excessively tall towers, because that means more wood, more mass, and it hurts you to have an over-designed tower. The same thing goes for the width of the base. We've identified the minimum dimensions of the test surface to be 55 and 32 centimeters. So, why would you want to go bigger than that? Because that adds more wood that you don't need, and it works against you in the scoring. So I would say take a look at those and do more pragmatic designs to say, I don't want to do too excessive so that I can't test on the test apparatuses. There was also a question here about how do I make the towers lighter? Again, that's the whole trick behind this, and what recommendation I can use for you guys is that this year it's all about segregating the wood members by density and selecting the right cross-section dimension that you need for the pieces that hold more of the load than others, and that's the whole trick. And so I would say keep going down that route, and if you don't know where to start, we have the templates out there on the website for you to use that'll give you a compliant tower to the dimensions, and it will hold the full load if you build it correctly. The video shows that as we build it. It's a good starting point to look at where members are too big, and that you can reduce those members by cross-section, and also screen the wood for lower densities to drop down the mass of the structure to score more. There's another one about what is the length or the dimension for the Division B circle. For Division B and Division C, it's all the 29 centimeter diameter circle that is applied for the bonus. And it's the same for both Division B, Division C.
Chuck, or Greg, could you talk about this one question here that asks about the minimum opening size at the top of the tower to allow the chain and hook to fit through?
Well, so there does have to be a minimum opening size. The chain and hook, the eye bolt is defined in the rules. The chain is not clearly identified in the rules, but I would tell you that if your eye bolt can pass through there, hopefully the chain would pass through there, because we're trying to use a relatively light chain. And so that is, like I say, defined in the rules, the diameter of the eye bolt. So if you get an eye bolt, you can then measure that. I don't know what that is off the top of my head.
I think it's a 1 inch. Let me, if I could add to that too, the opening has to be able to support the load block, and pragmatically, you'd want to make it easy for you to mount that during the actual competition. So, the students can take apart the load block assembly. We don't recommend that, but they can. They have to put it back exactly as we have it. But it takes time to do that, and that takes away from loading and other things. So pragmatically, I would say design your towers so that it's easier to put the load block in, including the eye bolt and the chain and all that. But it's up to the students to make a design that works best for them, even if it's problematic to do those mounting of the loading assembly.
Yeah, Chuck, it's a 1 inch nominal eye bolt outside diameter. So you'd think that you'd have to have at least an inch in there to get that eye bolt through, and then you can hook your chain on. But good points on the loading block and fitting it.
Hey, I saw one about the length of the chain. That was kind of current here. A lot of times, you have a long chain and you have a big tower and you have very short children, especially in the Division B. And a lot of times it's very hard for them to put all that together in a fast manner and not damage the tower. And what I always say is, put the tower on the ground, feed the chain in through the tower, and pick the tower up through is a lot easier for the students to do that are relatively short and can't, hold this very long chain really high and have somebody else hold the tower. Just put it on the ground and feed the chain through and pull the tower up through is a quicker way for those shorter people.
Hey guys, there's a couple of things in the Q&A asking about it. Kind of the theme is like either what type of wood or mixing and matching like balsa wood and basswood in their tower. Could you guys just kind of touch on that as a strategy and an approach? One, is it allowed? And two, thoughts.
You can use any wood that you really want to use. You can use oak, anything that you want to use. There's no limitation on the type of wood. But what I'll tell you practically is balsa is the lightest pound per pound. And so you probably want to use balsa wood. I will tell you all the winning towers in the competitions this year have been exclusively balsa wood and very small members. That's how they're getting, below 7, below 5. They're not using the heavy woods, and they're very careful with their glue. They use just the amount of glue they need. Chuck, you want to add to that?
No, you're spot on, and I would say that it's also about screening on the density because of the wide performance range on balsa wood. That you can get less dense that's lighter and more dense that's heavier and still be in the balsa wood category. And so again, you pick and choose what densities and what type of wood you need for the members that carry more load or less load, and you select the cross section that you need for that as well. But any wood is good, but it adds the mass. And there's a question there about, is there a min or a max mass? The calculation is a strength ratio, so it's the load divided by the mass. So you want to minimize the mass. So Greg has had experience with ones that are less than 10 grams and hold a full load. I've also had it, and so those are going to be the ones that are competitive. So we're really talking about very few pieces of wood and very light wood to get you to be less than 10 grams for towers.
Hey, we're coming up on time, guys, and there's one real interesting one I was hoping we could get you to talk about. And this team was looking for recommendations on transporting their tower to the tournament. They said they have a cardboard box, but they're trying to make sure that they're, all their hard work actually makes it to the tournament to be tested. Do you have any recommendations or ideas on stuff to use to make sure the tower goes safely?
Well, certainly you can use a cardboard box and just make sure that it's somehow you're not having the tower bouncing around inside of the box. You kind of want to secure it in place a little bit so that there's something there to absorb the impact. But I have seen everything from a cardboard box to a plastic box that has a sealing lid to a box that was made by a father that was unbelievable. That's how they distracted him from helping build the tower. They said, build the box that we're going to carry the tower to the meet-in. So any of those will work. It's just trying to protect your device, but you still want to handle it as carefully as you can.
I could try to quickly answer a couple other ones that popped up here. What type of glue is recommended? There's a variety of glues out there. If you're talking about towers that are less than 10 grams, you're talking about glue that's probably less than 1 gram in total. And a good rule of thumb is if you see the glue, you've used too much. But some people use diluted wood glue. Some people use some of the gap filler crazy glue. Some use Gorilla Glue, which tends to be a little bit heavy, but that's all part of the trick of trying to make your tower as light as possible. And whether a 3-sided base is better than a 4-sided base, and is it going to hold more? That's the whole gig around this event here, is the trades that students have to go through to see what is the optimal design and whether they can build it consistently with bond joints and selection of wood to make it hold the most and get the best score.
Right. On that note, guys, we've hit time. I want to thank everybody for coming out, and also, but more importantly, can we give a nice thank you to our experts who gave up some time this evening and have been working hard on these events this year. So thank you guys for sharing a bit of wisdom with everybody as we hit the real heart of tournament season.